Hi everyone, good evening and welcome to this sum up series, and today is the first sessions for this network subjects. So network subject, it's a backbone to many other subjects, like let it be analog circuits up to some extent in the control systems, up to some extent in digital. And if you take any core topics, everywhere you have this network directly or indirectly, right? So, but from this particular subject in the GATE exams, okay, so around 9 marks to 10 marks of questions we are getting, okay. So the weightage is around 9 to 10 marks. And again, there are some particular area from where mostly questions are targeted, okay. So the list is quite big actually. So when I teach in the class, I have divided the entire syllabus into 13 topics. So like fundamentals of networks, network theorems, fundamental of capacitor inductors, step or DC response of RLC network concept using Laplace, two-port, sinusoidal states analysis, parameter of AC waveform, AC power analysis, electrical resonance, locus diagram, AC transients and phases. I mean, those who have learned from me, you might have seen like this is the sequence I used to follow in the class. So let's get started with the fundamentals. Again, the intentions of this session is what? The intention of this session is to make sure like any, like the questions which are coming very regular in the GATE exam, somebody shouldn't miss it. Or we want like, in other words, I want to say these are the kind of expected questions that you can have in the upcoming GATE 22 exams. So coming to this fundamental of network topic, okay. So in this fundamental of network topic, there are some area from where most of the questions are targeted. So let me tell what are these area. So if I see from this fundamental, okay. So generally, okay, one question you can expect from the inspection methods. Now, what is the meaning of inspection method? Meaning of inspection method means there won't be any particular methods. You have to use the KCL, KVL, Ohm's law to get to digit answer. That is called inspection method based questions. The second category is based on resistance reduction technique. This is the category 2. Resistance reduction technique. And the third one is what is based on the mesh or nodal analysis. And again, among this mesh and nodal, again, most of the times the questions are inclined towards nodal. Generally, in the GATE exam, they will not be telling you solve this question by this method, solve this question by that methods, because a single circuit, it can be solved in n different ways. But which is the right approach? So that depends on your experience, how easily or how quickly we are able to get the solutions. The corresponding method should be selected depending on the questions, how it is framed. Okay. But mostly, even though fundamentals is a big topic, I take around 16 hours to teach in the regular class. But mostly, if you see, like in a broader way, these are the 3 segments from where questions are being asked. So, and apart from this, in so much of fundamentals also, they may ask some questions from long time they haven't asked. So I'm expecting they will ask this year. So let's start with the first questions. See, this question I have taken here. See, the current flowing in an ideal conductor is plotted in the figure. Okay. So the current flowing in the ideal conductor is given. So the IT expression is given here. Which of the following plot corresponds to charge transfer to the conductor? Okay, so basically here the current information is given and they're asking you to find the charge information. Okay, so what is the logic actually? So how do you solve it? What is the logic? Tell me, what is the logic? Or can you guess which is the correct option? Those students who are a little bit good in maths or kind of some sort of signals, you should be able to tell me what will be the right answer. By observing the option itself, you need not to solve it properly. you can, if you are good in signals, you can easily tell which option is most likely or which will be the right option for this. What is the answer? Rupali, Akhila, Renu Gadevi, Praveen Kumar. Yeah. So what is the logic to answer this problem? So we know, like IT is equals to dq2 by dt. The rate of change of charge flow is nothing but the current. So in this case, so if this is true, then I can say qt is equals to integration of it dt. That means if you are differentiating q, you are getting I. If you integrate I, you'll get q. So you have to basically integrate this IT waveform. And in signal system, you have studied this. How do you integrate it? Okay. Anyway, you know very well, integrations always give the area under the curve. So you have to basically integrate this waveform. So the corresponding answer will be the right answer for the charge. So if I ask you to integrate this, you see here, till 1, so the net area is 0 because integration is area under the curve. So till 1, so I'm getting it is 0. Then between 1 to 2, so if I ask you what will be the amplitude of integration of this IT up to 2, so that is nothing but the net area accumulated up to 2. That means if I'm plotting a waveform and this is your 1, this is your 2, if I ask you what will be the amplitude at 2, that depends on what is the area of this function up to 2. So area of this function up to 2 is basically 1. So here it is 1. Then between 2, then again if I ask you what is the area up to 3, then what is the answer then? This area is 1, and this area, if I ask you, I mean this rectangle which I'm highlighting, width is 1, height is 2. So this is basically 2. So what is the total area up to 2, up to 3 is 3, because 1 plus 2 is 3. That means the total area accumulated up to 3 is basically 3. That means at t equal to 1, the amplitude is 0. At t equals to 2, the amplitude is 2 because the net area is 2. Then at t equal to 3, the amplitude should be 3. So here, this should be 3. Okay. So then what's going to happen? From this itself, we can easily tell the answer is option A. This is what is matching. Then what is going to happen? Then if I ask you what will be the amplitude at 4? So what will be the amplitude? This is happening at 3. Okay. This is happening at 3. Then what's going to happen at 4? So 4 means what is the net area up to 4? So this area, if I again ask you, so this area is minus 2. So the total area was 3. 3 minus 2 is 1. That means at 4, the area will be 1. So this is 1. Then if I ask you what is the total area up to 5, then this is 0. So it will be again going to 0. So if I see, this is matching with option A. So A is the right answer for this question. So this is based on the very fundamental. Okay. So the intention of this question is, so see, everybody knows like current and discharge are related by this integration differentiations only. But the intention of this question is whether you are good to deal with the mathematics or not. Whether you are good in the differentiation or integration or not. That's what it matters. So such model of questions has not been asked from last couple of years. So I expect in this upcoming 22 exam, 1 questions from these segments they may ask. Well, students who are watching live, please give a thumbs up to the video. And if you haven't subscribed, please subscribe to our channel. So now let's go to the second questions. The second question is, current and voltage across the device are given in the figures. What is the energy in joule approximately absorbed by the device between 0 to 2? Okay. So what is given? So we have a device, the voltage and currents are given. Voltage is given and current is given. What is supposed to find? What is the energy absorbed? So you have to find the energy. Okay. So how do you do it? Because, you know, if voltage and currents are given, you can get the power. So power is equals to product of voltage and currents. And I hope you know the relation between energy and power. So if PT is this, so what is the relation between energy and power? So if I integrate the power, so I'll get the corresponding what? Energy. Right? So the energy and power are related by this integration relations. Energy is integration of power, or power is differentiation of energy. Now, what is the limit? That depends on, like in what interval you are interested to find. Let's say in this case, so they're asking to find the energy in the interval 0 to 2. So that's why in this one, I'll be giving the range from 0 to 2. So in this case, E is nothing but integration of 0 to 2 Vt into It. Okay, so Vt into It. So Vt expression. Okay, so let us divide this into two segments. So one segment. So overall integration is up to 2. One segment I'm taking 0 to 1. In the 0 to 1, your Vt is 10. So this is 10 multiplied by, between 0 to 1, if you see, this is the variations. And this expression is given 1 minus e raised to power minus 70 dt. Plus integration of 1 to 2, between 1 to 2. So this is 0. So this is 0 into e raised to power minus 7 t minus 1. And this is dt. So the second integration is anyway 0. So the first integrations. Anyone? What is the answer? Anybody solved it? Tell me what is the answer. So now if you simplify this, so this is integration 0 to 1. This is 10 dt minus integration 0 to 1, 10 into e raised to power minus 70 dt. Okay, now if you simplify this, this is 10 and the limit, if you substitute, this is 0, 1. This is minus 10. This is e raised to power minus 70 divided by minus 7. Again, the limit is from 0 to 1. I think we can take this 10 outside. So this is 1 minus 0 is 1. And this is plus 1 by 7 because 10 I have taken it out. And this is e raised to power minus 7 minus 1. Okay. So take a calci and simplify this. And if you simplify this, this answer is happening to be 8.5 Joule. Are you getting the same answer, 8.5? Yes or no? Are you getting the same answer, 8.5? Or something else? So in this case, again, the logic is simple. Now, why I have selected this particular question is, generally, whenever the question is from the energy, people used to think it is I square RT kind of things. Well, that is with respect to the resistor, right? But in general, any electric device, if you know the voltage currents, we can get the power. And if you integrate the power, we get the energy. So in the previous case, we have dealt with the waveform kind of things while integrating. In this case, we have dealt with the expressions. So the way the question is given, accordingly, we have to think our mathematics. Hopefully, this is clear. Anybody who is getting something else? 8.5 is the right answer. You please try it out. So the calculation, if you do by the calci, it is 8.5 only. Well, such kind of 1 mark questions is most likely to come, okay, which is like, so this is what I mean by the circuit solution by inspection methods. Inspection method means there is no methods for this particular, these things, like you just have to use your experience, how well you are with the KVL, KCL, Ohm's law, and accordingly you can do. Well, the question is, consider the circuit shown in the figure below. Here it is saying like if I1 equals to 1, then which of the following set of values of alpha and R is not correct for the circuit? Yes, I'm waiting for 1 minute of time. Let me see how many of you are answering. So what is given in this case? So in this circuits, the current I1 is given. This is the current I1 you see here. This is given is 1 ampere. Which of the following set of values of alpha and R is not correct for the circuits? I mean, you have to see the options. Which value is not correct with respect to alpha and R values? The circuit looks quite simple. It's a simple series circuit only, right? So let's see. So if I write the KVL in this one, what do we get? 120 minus alpha V1 minus I1 into R minus 20 I1 minus 12 I1 is equals to 0, isn't it? 120 minus alpha V1 minus I1 R minus 20 R minus 12 I1 equals to 0. So here, okay, what is known to me? Here I can see the I1 is given 1. But what is B1? B1 is defined here, right? This is what your B1. If I ask you what is B1, B1 is 12 into I1 because I1 is 1. So B1 is 12 itself. So let us substitute these values. If I substitute these values, this is 120 minus B1 is 12, right? So it is 12 alpha minus I1 is 1. So this is R minus 20 I1 minus 12 I1, 32 I1. So 32, right? I1 is 1 equals to 0. So what is the equation we are getting then? So we are getting 12 R alpha plus R is equals to 120 minus 32. Now what is this 120 minus 32? This is coming 88. So we are getting the equations that 12 alpha plus R is equals to 88. So we are supposed to find which of the following set of value of alpha and R not correct for the circuits. Let's check with option A. So option A, if I say, so whether this option A is satisfying this equation or not. 12 into alpha is 12 into 2 is 24 plus 64. So this is 88. Okay, so option A is satisfying, but we have to find not correct. Option A is correct. I mean, option A will satisfy these equations. Option B, if I check, again 12 alpha, 12 into 5 is 60 plus 28, that is 88. Again, it is satisfying. So B is also satisfying. What about C? 12 alpha, 12 into 6 is 72 plus 80. So this is coming 152. So this is not satisfying. And if I check for option D, so 12 into alpha is 36 plus 52. So this is again coming 80. This is all satisfying. So only option C, that means 6 and 80, this is not satisfying. So naturally, the answer in this case is option C only. Yeah, well, I mean, why you are not responding? Praveen, Akila, you should respond. These questions are a bit logical, of course, not very straightforward. And you can't expect so much of, extreme straightforward question in the GATE exam, right? So a little bit logic will be there. Okay. So the answer is option C for this. Yeah. Let's see these questions. So this kind of question is most likely to come. So this is what I am solving the questions which are based on the inspection methods. See, like the kind of 1 mark or 2 mark question, if you see in the fundamentals, somehow you'll find like some circuits, they'll be giving some voltage currents will be given, and they'll be asking you to find the voltage current in some other branch elements. So, and it is wise to solve this kind of questions using this inspection methods, or by how effectively use this KCL, KVL, Ohm's law to get the corresponding answer. Well, the question is in the circuits on below, the voltage V1 and V2 are. So in the circuits, we have to get the value of V1 and V2. So how do you get the value of V1 and V2? Any answer? So this is V1, right? So this is V1. I mean, the voltage of this is V1 and the voltage of this is V2. So I have to find this V1, V2. Do remember, the voltage of current source can be anything. It depends on the surrounding circuit elements, isn't it? So how do you find? Now, some of you may say, sir, I'll be writing a KVL because this current is known to me 10. Okay, then I'll be writing a KVL. But how do you write the KVL? This resistor value is not given, so you don't know what the voltage of this. And if you write a KVL in this particular mesh, so this is V1, V2, you'll not have any benefits. Similarly, if you think to write in this one, there is also no benefits. Why? Because this voltage, you don't know what is the voltage of this 9 ampere. So you know the V2, you have this voltage 4 into 1, but you don't know what is the voltage of this 9 ampere. So there is no benefits. So what we should do then? So what we should do means, so our approach is to get the unknown currents. I mean, I'll be trying to get the current through all the branch. If I get the current in all the branch, then I'll be selecting some mesh or loop. So by writing the KVL there, I'll be getting my answer. Suppose, for example, I'm getting the current in this branch and this branch. Then I can get their corresponding voltage. Then if I write a KVL in this particular mesh, I'll be getting the corresponding answer. Are you following or not? So that's what we should do. Similarly, like if I'm getting the current in this branch, then I may write a KVL in this particular mesh to get the corresponding V2 values. So the first approach is, let us try to get the current in each branch. So what I'm doing is, so let us name this node is what? Let's name this node is O. Okay. So in this one, I know this is 36 and 9. So let's say I'm interested to get the corresponding currents. So let me tell this current is IX. So if I write the KCL at node O, so what do you get? So the equation is incoming current is 30 only, and the outgoing current is 6 plus 9 plus IX. So what is IX? IX is 30 minus 15, that is 15 amperes. So you got IX current 15 amperes. Okay, na? Then using this, what you can do is, so okay, so what are the unknown branch currents? Unknown branch current is, this is IX, and let's say this current is IY, and this current is IZ. So these are the only three branch current which are unknown. So I got IX. Then how do I get IY? To get IY, I can write the KCL equation at this node. So let us name this is node A. So if I ask you to write the KCL at node A, the incoming current is 10 plus 6 is the incoming current. Outgoing current is IY. From this node, the outgoing current, I mean, there are three branches, 10 and 6 are incoming and IY is outgoing. So what is IY? So your IY is equals to 16. So IX is 15 and your IY is 16. And finally, you have to get this IZ. So you can write a KCL here again. So let's say this branch, this node is B. So if you write the KCL at B, the incoming current is IZ plus 9 and the outgoing current is 40. So what is IZ? So IZ is 40 minus 9, which is coming 31 ampere. So IZ is 31 ampere. So you got IX, IY, and IZ. Okay. So once you got these currents, so how do you get V1? Let's say if I ask you. So if you write the if you write the a KVL equation at this particular mesh, so that you will get in terms of V1. That means if I write the corresponding KVL, so V1 minus 2IY plus 3IX is equals to 0. Wherever current is entering, plus to minus, wherever current entering, plus to minus. So if I see minus 2 plus V1 minus 2I and plus 3IX is equals to 0. So what is V1? So V1 basically is 2IY minus 3IX. So 2 into 16 minus 3 into 15. That is 32 minus 45, which is minus of 13 volts. Minus of 13 volts. So V1 is equals to minus of 13 volts. So, and what is this V2 then? So coming to V2, how do you get V2? Now to get this V2, I'll again check which particular mesh I should select so that I'll be getting the value of V2. So which particular mesh I should select? So I can select this one, the outer one, this one. Now you may ask, sir, why can't you go this way? I can't go this way because I don't know what the voltage here, the register value is not given. And in this way also I can go because I don't know what the voltage of this 9 ampere as of now. That's why it is wise to write the KVL at this particular mesh, which I'm highlighting now, right? So V2 minus 3IX minus 4IZ minus 4 into 1 is 4 is equals to 0. So V2 is equals to 3IX plus 4IZ plus 4. 3 into IX, 3 into 15 is 45. 4 into IZ, 4 into 31 is how much? 4 into 31 is how much? 4 into 4, 124. And this is 4. So 49 plus 124. Some calculation mistake is happening, it seems. Let's see. 3IX minus 4IZ minus 4. So 3ix plus 4. 3 into ix is 1545. 4 into iz 124 plus 4. So check it out. Okay. So check the calculations if anything. So, but the approach is this only. 45. Yeah, I'm doing a mistake, right? What is the mistake? The mistake is this is 40. This is not 4. This is 40. Yeah. This is 40. So it is 85 plus 124. And that answer is coming 209 volts. So it is in option C. So C is the right answer for this question. Now, what about this? In the following network, okay, equivalent resistance in our terminal AB is dash ohm. Okay, so this question is based on that resistance reduction technique. So in resistance reduction technique, there are so many approaches. Like you can get the answers by redrawing the circuits. Sometime, if necessary, you can do the star delta transformations. Sometime you can use the equipotential concepts. Like this, there are so many approaches. So depending on the questions, you have to select one. So this kind of questions, they used to ask in the class 12 exams, right? If you remember. But such questions are also being asked in the GATE exam. And almost every alternate year, one question is from this finding the equivalent resistance. So most likely those questions which are coming in the GATE exam, so we are able to solve them by using the redrawing, series parallel, and equipotential mostly, right? So these questions you can solve it. Now, can you tell me which approach will be best here? So I have to get the R equivalent here. So how do you solve? Can you tell me the approach at least? Anyone, please. So here, if I see, R equivalent, I'm interested to find from AB terminal, right? So very straightforward series parallel is, I'm not able to see very straightforward series parallel. And if you see the circuit is containing only resistors and so many leads and all are there, right? So what is the approach to solve them then? What should be the right approach? So actually, if you redraw the circuits, the series parallel things which are actually there, they are not visible in these original circuits, but if you redraw them, you may be able to discover like, okay, these elements are in series, these elements are in parallel, and accordingly you can proceed. So accordingly, if I see, this node is A, right? If this node is A, so this node is also A, this node is also A, this node is also A, this node is also A. So a connecting lead without any element in between, okay, the entire path is the same node. That means, I mean to say, if this is A, this entire path is node A only, because there is no element in between. So the entire, this is A only. So no need to think like these are different nodes, because it is a sorted path. This is the same node A only, right? So this is A, and this is B, this is B, and let's name this is C. Let's name this is C. Okay, fine. Now, if I ask you to redraw the circuits, how does this, this circuit will look like? So one thing is clear, right? So if I ask you whether this, like between A and C, which are connected. So between A and C, this 36 is connected. This 36 is connected between A and C. And where this 36 is connected, this is between B and C, right? This is between B and C. Okay. And between A and B, this 36 is connected. Well, if you see one thing here, okay. So do you agree like this? As you said, this and these are the same node. So what is the point then? If they're in the same node, so you can say this is sorted only. So if I ask you to redraw the corresponding circuits, how does it look like? So it will be something like this. So this is node A. This is node B. Okay. So this is the, let me take the node C. So let me take node C. So between B and C, you have 36. So this is one I have shown you, 36. So this is your B. Then between A and C, you have this 36 and this 36. These are in parallel, na? So 36 parallel with 36 is 18. So this is your 18. So this is your C node. Okay. So I have covered this register, I have covered these registers, and I have covered these registers. Having said that, okay, so we have done with AC. AC we have done AC, that is coming 18, and between BC we have the 36. Then where I need to show this particular 36. So this particular 36 is between A and B only. That is between A and B only. So, and where this will come, I mean, this 36, and this 36. So, where are they connected? So, they are between what node? They are between what node? So, that is, and what about this node? This node is also A, na? Because this is also same path A. So, these 4 registers are connected between the same node. So, if they are between the same node, so what is it? This is like short circuit, na? So if I ask you to draw the corresponding diagrams, so this will be your 36. Okay. And this is also your 36. And this is your short circuits. So if you ask me, sir, where this 36 is coming, I mean, where this 36 is coming, this 36 is from this 36, this one. Okay. And which is this 36, this 36, this 36. Okay. So now if you try to find out what is this RAB, so your RAB, if you ask me, so 36 in parallel with this sorted path, that is 0. So if you see equivalently, okay, so how many resistance we have actually? So if you see from AB point, so one resistance is 36, other resistance is 18 plus 36, and they're in parallel. What is RAB then? This is 36 parallel with 18 plus 36. So this is 36 parallel with 54. And if you solve it, so this is coming 21.6 ohms. This is coming 21.6 ohms. I'm sure this is clear to all of you. So this is node A. Again, I'm just revising you. A. This is also node A. This is also A. This is also A. This is also A. This is also A. This is your B. This is your C. This is your C. This is your C. So first, this 36 is from this one. This 36. Then this 36 is from this 36. And this 18, okay, is from this 236. So this one is inside done. Okay. Then what is left? So we are left with 3 more 36. I mean, this 36, this 36, and this 36. My claim in this case is all these 36 are between the same points. A. So the same point, what is the net resistance only? I mean, it's like a point you have A, and you are simply stretching the same point A. So what is the net resistance? 0. That is short circuit. That's why I'm saying I'm replacing all these 3 registers by a sorted path. I mean, the equivalent of this is 0 only. So this answer is 21.6 in this case. So one more similar question I have taken here. So please try to answer this, or at least you need to tell me what should be the approach to solve this problem. The question is, the resistance R looking into the terminal AB in the circuit is dash ohms. So can you at least tell me what is the approach in this case? What approach you should following in this case? You refer the questions of GATE 2016, GATE 2018. There is one compulsory question from this resistor reduction techniques. So generally the questions are from the redrawing the circuit the way we have solved the previous questions, or it can be from the star delta, or it can be from the equipotential concepts. So one question I have taken from the, by redrawing methods. These questions I have taken, if you see the architectures of the circuits, you should get the idea or thought. So this is from what? Star delta, delta star transformations. Because if I'm observing what is RAB, directly we cannot tell which are in series parallel. So then what I should do then? Then I should be observing whether the star delta transformation is possible or not. So what is the benefit of doing star delta transformations? It will eliminate some of the unnecessary loop or mess which is complicating the circuits. And once you are converting a delta to star or vice versa, if the circuit is simpler, then you can again use your normal series parallel concept to get the equivalent resistance. So in this case, I'm going by this star delta transformations. So I have two options actually. One of the option is you can think of this is a star network. You can have its equivalent delta, which one I'm highlighting. Otherwise, you can think this is a delta, you can have it star. Or you can think of this is your delta, you can have it your star. So three options are there. Whichever is comfortable to you, you can go through it. So what I'm doing is, so let me convert this delta into star. So this delta I'm converting into star. So this value, let's call this is RA. This value, let me call it is RB. And this value, let me call it is RC. So if I ask you what is RA, so because this is coming from this points and to this point, this 5 ohm and 25 are connected. So this is 5 into 25 divided by all three resistors which are forming the delta. That is 5 plus 25 plus 20, which is 125 divided by 50, isn't it? If it is 125 divided by 50, so this is coming how much? 2.5. 2.5, isn't it? 2.5 ohms. Similarly, if I ask you what is your RB, so this is your RB. So this point is connected to this 25 and this 20. So this will be 25 into 20 divided by 50. So this is your 10 ohms. And if I ask you what is your RC, okay, RC, I mean this resistor. So it is again product of 5 and 20. So 5 and 20 divided by sum of all, that is again 50. So if you solve this, so this is coming here 2 ohms. So after getting these three values, so what I'll be doing then? I'll be redrawing the circuits. So if I redraw the circuits, how it look like? So you have this 2.5 ohm, these things. Then, okay, so you have a resistor like this. So this is your RA, which is 2.5 ohms. Then you have a resistor here, whose is RC. RC is 2 ohms. And you have a resistor here, RB, which is your 10 ohms. Okay. So then to this, we have this 4 ohm. And then from this, we have this 2 ohms. And then we have this 5 ohms. So this middle delta, okay, this I have replaced it by star. And what are these star? This is what is the corresponding star. So 2.5 is the value of RA, and RB is 10, and RC is 2. So this is your RA, this is your RB, and this is your RC. The same name, whatever nomenclatures I have used here, the same nomenclatures I'm again using here. And this 2.5 is the externally connected 2.5. And this 5 is this externally connected 5. And this 2 and 4, they are RGTs. This 2 and 4 are RGTs. So now it is very simple, right? So if you want, you can again further redraw the circuits. So 2.5 and 2.5 are in series. So equivalent it is 5 ohms. Then from this, there are two parallel paths you can think of. One is 12 ohm, 10 plus 2. Other one is 2 plus 4 is 6 ohms. And then you have your 5 ohms. So this is your A, this is your B. So if I ask you what is your RAB, so the answer is 5 plus 6 parallel with 12 plus 5. So this is 5 plus 72 by 18 is 4 plus 5. So this answer is coming 40 ohm. This is my answer, 40 ohm. What is your answer? Are you also getting the same? just this, is it gate 23 batch? No. This is, I'm doing for gate 22 only. And now one thing is, which is like, like trending is the gate exam is getting postponed. So most likely the situations what we have now, so most likely it seems like that only. Like, it might be postponed. But as of now, there is no official notifications. But today I was reading somewhere in one article, like IIT Kharagpur director saying whether the gate exam will be conducted or not in the previous earlier announced date, it will be notified to you soon. Okay. So hopefully there will be some changes. And because the way it is happening, and if you see the news and all, the peak will be happening on the February 1st week only. So let's see. And if it happens, then it will be first time in the history. It never happened in the gate history, like gate exam has been postponed. Any kind of, disturbances in the schedule, it has never happened so far in the history. If it happens, we have to accept it. And the pandemic is the only cause for that, right? Anyway, so what is the, let's try these questions. In the circuits on below, V1 is 28 volts, okay? The value of I and alpha respectively. So I have to find the value of I and alpha, provided V1 is 28 volts. So what is the approach in this case? In this circuits, V1 is 28 volts. Then what is the value of this I and alpha? Although there could be many approach, but these questions I'd like to solve using the nodal analysis methods. So what I'll be doing is, and intentionally I have taken the circuits, so where I have to use the concept of super node. So, okay, if you see this, so this is 20 volt means, so this voltage is also 20 volts. And if this is 24 means, so this voltage is also 24 volts. Then let us write the super node equations. Okay, I mean by taking this as the super node, which I'm highlighting. Okay, so now if I ask you to write the corresponding equations, so to the highlighted nodes, how many branches are linked? 1, 2, 3, and 4. So in this path, it is V1 minus 20 by 2. That is for this path. And then for this path, it is minus 1. And this current is given I here, right? This is your I. I mean, the one which, I mean, we are supposed to find I and alpha. This is what your I is, and this is your alpha is. So minus 1. And for this branch, so I'm writing here it is plus I because it is outgoing. And then I'm writing Ix. But what is your Ix? Ix is 20 minus 24 divided by 4. This equals to 0. Okay. Once again, so if you see this, so this is the super node I'm selecting. So to this super node, 4 branches are linked. This branch, the corresponding term is B1 minus 20 by 2. This branch is minus 1. This branch is plus I. And for this branch, if I ask you what it is 20 minus 24 divided by 4 only. So now, if you simplify this, so this is coming V1 minus B1 by 2 minus 10 minus 1 plus I. 20 minus 24 is minus 4. Minus 4 by 4 is minus of 1 equals to 0. So if you simplify this, so this is coming B1 by 2 plus I is equals to 12, isn't it? Or you can say V1 plus 2I is equals to 24. So this is what one equation we are getting, right? And V1 is also known to me, right? V1 is also given in the questions, which is 28. you can substitute here 28, then 2i is equals to 24 minus 28 is minus 4. So I is equals to minus of 2. So the value of I is minus of 2. How much you are getting? Is there any calculation mistake is happening? Let's see. V1 minus 20 by 2 minus of 1 plus I plus. So actually this should be minus sign, na? Ix if I'm writing. So 1 second, one mistake is happening. This should be minus sign. Why it should be minus sign? Because Ix if I'm writing in this direction, current is incoming. So it should be minus. If it is minus, so this will be minus plus 4. So this will be plus 1. If this is plus 1, V1 by 2 plus I is equals to 11 minus 1. Okay, that is 10. This is your 10. If this is 10, 2V1 plus, sorry, V1 plus 2I is equals to 20. This is your 20, not 24. If this is 20, 2I is equals to, this is how much? 20 minus V1. V1 is 28 now. So this is your minus of 8. If this is your minus of 8, then I is equals to minus of 4. So that is a negative sign mistake I did. So I is equals to minus of 4. So the answer will be in this case. Answer will be B in this case. Okay. So we got the value of I, which is minus 4, but we have to find alpha also. But if I observe the options, option B is satisfying because this is the option which is containing I value is minus 4. But if you want to get alpha, how do you solve? How do you get alpha? So what I can tell is, if I observe this particular circuits, so I can say, so this load voltage, which is 24. So 24 minus V1 is equals to alpha into Ix, isn't it? 24 minus V1 is equals to alpha Ix. But what is this Ix? So Ix is this current, na? This is Ix. So Ix is equals to 20 minus 24 divided by 4, which is minus of 1. So if you substitute here minus of 1, so 24 minus 28 is equals to Ix is minus of 1.
எங்களுடைய கருத்து வந்து இதுதான். இப்படிதான் எங்களுக்கு பார்த்தோம்னா தோணுச்சு. உங்களுக்கு என்ன தோணுச்சு அப்படிங்கிறது தெரியல. உங்களுக்கு இதே மாதிரி தோணிருக்கலாம், சில பேருக்கு வேற ஏதாச்சும் தோணிருக்கலாம்னு வைங்களேன்.
So alpha is equals to 4 and the value of I is equals to minus of 4. So naturally the answer is option B only. Well, so this question I have taken. This question I have taken in terms of so in this case we are supposed to find
பாத்தீங்களா, இது வந்து இன்னொரு ஆங்கிள் எடுக்கப்பட்ட இன்னொரு வீடியோ. இந்த வீடியோவை பார்த்தோம்னா அந்த பொண்ணுக்கு கண்ணு தெரியாது. அதனால
but my interest is to solve this problem using the mesh analysis. So how do you solve it then? So what is the approach? Any special answer for this or anything, like something special you're observing in the circuits? As I said, I want to solve this question using mesh analysis. So let me denote this mesh current is I1. This mesh current is 2 ampere. You can see because this 2 ampere is in outer boundary. So the mesh current is 2. And this mesh current, so let us take this is I2. And this resistance value is also actually given. This is 2 ohms. Okay. So it is 2 ohm. Fine. So how do you get V1? So if you want to write a Kvl equation in the first mesh, so it will not solve your purpose because so you don't know what is the voltage of this current source. Nah? You don't know what is it. So writing some Kvl equation directly in any of the mesh will not serve your purpose. Okay. Then what I should be doing then? Then I'm interested to write the Kvl equations. But here the corresponding Kvl equation, it will be the super mesh equation in this case. Why the super mesh? Because if I want to write the point is in this case, if you see this particular current source is bifurcating mesh. So if I'm denoting this is mesh 1, this is mesh 2. So mesh 1 and mesh 2 are, in between them, we have a current source. And what is the voltage of the current source? You don't know. And that's what we learn. Whenever a current source divides two meshes, in other words, if the current source is in the outer boundary like this, we don't need super mesh. But if a current source is in between or it is divided into meshes, then definitely you need in that case what? The concept of super mesh. Why you need super mesh concept? Because you don't know what is the voltage of this current source. Then, okay, so now let's write the corresponding equations. So what is the super mesh if you ask me? Okay, what is the super mesh if you ask me? So the super mesh is like this. So let me highlight here. So this is what is the super mesh. You see this, the blue line, the dotted blue line, which I'm showing. So this is what is the corresponding super mesh. Now, if I ask you to write the corresponding equations, what do you get? 14 minus 3i1. 14 minus 3i1, right? So this is 14 minus 3i1. What is the voltage you should be writing in this case? It is minus of 3 into i1 minus 2. So from where this 2 is coming, this is what 2 is. i1 minus 2. Okay. Then minus 6 into, so I'm done with 14. I'm done with 3. I'm done with this 3. Then I have to write the equation for this 6. 6 into, so this will be your I2 minus 2. I2 minus 2 minus of 2by. That means then I have to come here. Minus of 2by. Then minus of 2I2 is equals to 0. Right? So this is what you are getting. Okay, now. So now let us simplify these equations. So 14 minus 3i1 minus of 3i1 plus 6 minus of 6i2 plus I2 minus 2, we said this one, right? I2 minus 2 plus 12 minus of 2by minus of 2I2 is equals to 0. But where this by is defined, the by is defined here. This is what your by is. So what is this by? So your by is your 3 into I1 minus I2. I1 minus I2. Because if I ask you what is the corresponding voltage here, so it is 3 into I1 minus I2. Not I1 minus I2, I1 minus 2 it is, because I2 is this current. Sorry, this is I1 minus 2. This voltage. So this voltage is 3 into I1 minus 2. Because this side current is I1 and this side current is 2. So it is 3 into I1 minus 2. So in place of by, you can substitute that. So 14. So if I collect the term corresponds to I1, 336. So 14 minus 6I1 minus, if I collect the term with respect to I2, 6 minus 2 minus 8I2. Okay, minus 2by. So minus 6 into I1 minus 2. Okay, I have done for this. Then the constant term if I observe, so 12 plus 6, 18 plus 14, 32. Plus 32 equals to 0. So this equation is coming only in terms of I1 and I2. So if you simplify this again, this is 14 minus 6I1 minus 8I2 minus 6I1 plus 12 plus 32 equals to 0. Now again, if you separate the term, 6, 6, 12 minus of 12I1 and this is minus of 8I2. Minus of 8I2 is equals to minus 12, minus 32, minus 40. Let us multiply minus both sides. These all will be plus. So this is 12I1 plus 8I2 is equals to 32 plus 14 is how much? 46 plus 12 is 58. I hope all of you are getting the same answer. 12I1 plus 8I2 is equals to 58. This is one equation we are getting, relating I1 and I2. What is the other equation we'll be getting? Other equation we'll be getting by correlating this particular current source. So if you write the KCL at this particular node, so what is the incoming current? The incoming current is 7 plus I2 and the outgoing current is I1. So to this node, 7 is incoming. So this is incoming and this current I2 is also incoming. What is outgoing? So this current is outgoing. So incoming current 7 plus I2 is equals to I1. So what do you get? Your I1 minus I2 is equals to 7. So this is second equation. I1 minus I2 is equals to 7. If you simplify this, so let us multiply 8 both sides. 8I1 minus 8I2 is equals to 56. So if you add both of this one, so 20I1 is equals to 14 and this is 11. So I1 is equals to 114 divided by this thing, 20. So I1 minus I2 equals to 7, one equation we got. And other equations, please check this one. So everything is fine, it seems, right? 20, 50, 100, 114, 58. So I check the calculation again, 1 second. 14 minus 3I1 minus of 3 into I1 minus 2 minus of 6 into, this is I2 minus 2 minus of 2py minus of 2I2. Fine only. 14 minus 3I1 minus 3I1. Okay, plus 6 minus 6I2 plus 12 minus 2py minus 20 equal to 0. Yeah, fine. 14, 6I1 and 8I2 minus of 6 into, in place of py, we said it is 3. So 2 into 3 is 6 into I1 minus 2 plus 32 equal to 0. Yeah. So 14 minus 6I1 minus 8I2 minus 6I1 plus 12 plus 32. Fine. Then your 12I1, 6 is 12I1 plus 8I2 is equals to 40. Yeah, 58. Fine only. So the approach is, once you get this value of I1, I2, you have to solve these equations. And once you get this value of I1, I2, then what is the next thing that you should do in this case? So once you get the value of this I1, I2, so the next thing that somebody should do is how to make use of this I1, I2 to get this corresponding value of V1. See, so how do you get this V1? So if you write the Kvl equation here, it is 14 minus of 3I1 minus of 3 into, it is I1 minus 2 minus of V1 equals to 0, right? 14 minus 3I1 minus of 3 into, it is I1 minus 2 minus V1 equal to 0. So if you get the value of I1, if you can substitute in these equations, then you can get the value of V1 here. So this one will be the approach to solve this question. Okay. So this model of questions you can expect from the fundamentals. As I said in the beginning itself, from this fundamental topic, so the questions you can expect from the resistance reduction technique, from the mesh nodal analysis, and it can be from the inspection methods. So these questions is from the basics, the first questions. Second question also from basics by correlating the energy power. Third question we have taken from the inspection method. Fourth question we have taken again from the inspection methods. Fifth question I have taken from the resistance reduction techniques by redrawing it. Sixth question is from again resistance reduction techniques but by using star delta. Next question is from nodal, and the last question I have taken from mesh. In nodal I have used the concept of super node, And in mesh, I have used the concept of super mesh. So if you see, like if there is any questions in the network from fundamental topic, so that questions is most likely to be asked from this model of questions which we have discussed today. I mean, this 6 to 7 questions. So that's not all for